set, go. All right, so this is our statistics unit, right? So for statistical questions, there will be variability in the responses collected. What does that mean? Someone tell me what that means.
It means that the question you ask, the answers, there should be different variety of answers, not the same answers, and not like a yes or no.
Exactly. Good. Or like if I went around and asked students, who do you have for math? I mean, there's going to be a little variability, but not much, right? Because there's only a limited number of math teachers in a building, right? But yeah, so Ava's right. Do not ask yes or no questions. That's not going to give you statistics. When you run statistics, you're not looking for yes or no questions. Don't ask questions with only one or maybe, two or very few answers. Be specific. For example, if you want to know how many hours spent at the park, you would not say, did you go to the park last week? Right? That's a yes or no question. You would say, how many hours do you, that's an error. You would say, how many hours do you spend at the, I don't know how to write, you guys. The part? No. How many hours do you spend at the park per week? That's a great question, right? Because it's not a yes or no question. And somebody could say, I didn't go to the park last week, so 0 hours, or someone could go every day for a couple of hours and, they could say 14 hours. So anyway, that's a good question. That's a good way to gather statistics. All right, so which of these examples is an example of a statistical question?
How many board games have you played in the past month?
I like it. All right, so what's wrong with the first one? What is the top selling board game?
That's a set answer, and it could also change too.
True, right. Yep. What about the third one? What's wrong with that one?
There's only one answer.
There's only one answer to that.
Yep. And then the last one, how many board games require a deck of cards to play? I mean, we could do a little research and figure out the answer to that question, but
that's going to take like a week or a year to finish.
Yeah. But letter B, that's a great statistical question because, there could be a very wide range of answers, right? Yeah. Y'all play board games? Who plays board games? Anyone?
I do.
You do? Monopoly? Any Monopoly players out there?
No.
I used to before 2020.
What happened before 2020?
Oh, I played board games.
Oh, but 2020.
But then I guess I just stopped.
Oh, okay. Well, I have a lot of happy memories playing board games growing up. People don't do that as much anymore. One time, our electricity went out and my whole family sat on the floor. We lit candles and we played Monopoly for forever. And that was one of my happy childhood memories. Just all 5 of us sitting on the floor with my parents playing Monopoly by candlelight. That was so fun. Anyway.
I didn't really like playing board games with my family because my sister would always win because she's a sore loser.
Well, it only takes one, doesn't it? Now I like playing cards. You guys like playing cards?
Yeah.
If we ever get together, I have the funnest card game. You guys would love it. It's called Squeak. You ever heard of it?
Yeah.
Oh my gosh, you would love it. You would love it. I'll have to teach you guys one day. All right, moving on. So here we have a box and whisker plot. And then number 3, of course, is what is that thing?
Histogram.
A histogram, right. So hopefully you guys, I'm sure you can look at a box and whisker plot and tell me all of these things, right? Can you tell me what the median of this one is?
33.
33. I agree with you. What about the Q1 or the lower quartile?
25.
25.
Yep. What about the upper quartile or Q2?
39.
39.
39. So what's our minimum number?
20.
And the maximum?
44.
44.
Beautiful, fantastic. Have we talked about interquartile range for this class?
Yeah.
I think we have.
Because 8th grade is also in statistics, and I can't remember. Actually, it's my algebra class is doing statistics right now too. And a lot of the stuff actually 6th grade and 9th grade overlap, which is kind of weird, but it does. So
I'm
if I
pretty sure
asked you,
we did.
what
I'm pretty sure we did learn about interquartile range.
interquartile range, who remembers how I would find the interquartile range?
You subtract Q1 from Q2, I think.
Yep, that's it. So 44 or 39 minus 25. What would that be? Who can do math in their heads?
14.
14. That was fast.
Yeah.
That was fast. What does the interquartile range tell us about? What part of our data does it tell us about? What percent of our data is from, well, I thought my pen was going to work. Oh, it is working. What part of my data is from here to here? What percent is this?
50%.
50%. So the interquartile range tells us the range of the middle 50, how spread out the middle 50% of my data is.
Mm.
Okay. But like I said, that's probably more of an algebra question, but you'll get there. Number 3, from the histogram, can I determine, so here's my histogram, right? This is the number of stage shows students watch, like if you go to a play, right? From this histogram, could I figure out the mean number of stage shows?
No.
No, I could
You don't
not.
have the exact numbers of the
Say it again,
exact,
Eva.
you don't have the exact numbers of the students' answers for
Well, so look at the second question. Can we tell the total number of students the histogram represents?
yes.
Yes,
Yeah.
we can. We do know how many students the whole histogram represents, right? Because we could count 3 plus 7 plus 6 plus 4, and that's how many students participated.
20.
20. Wow, y'all are so fast. But I don't know how many students watched exactly 6 stage shows, right? Or exactly 10. So that's why I would not be able to find the mean, but I can figure out the total number of students the histogram represents. Could I figure out the third question, the number of students that watched 11 or less stage shows?
Yes.
Yep, how many is it?
It would be
10.
10.
10, exactly right. Can I figure out the number of students that watched exactly 18?
No.
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 We can't figure that out. So histograms are good and they give us a lot of information, but we can't find some things, like we couldn't figure out what the mean is. What about with this box and whisker plot? Could we figure out the mean up here for the box and whisker plot?
Yes.
Yeah.
Can we? How would we do that?
You would add up the minimum Q1, median, Q2, and maximum, and then divide it by 5.
But so let's say, first of all, do we know how many people this box and whisker plot represents?
No.
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 So
Oh,
since we
okay.
don't know how many people it represents, we can't figure out what the mean is. We don't have any idea how many numbers were lined up in order to figure out that data, right? So this is still a good way to look at your data, how far, how far apart the data is spread, and the median, the lower and upper numbers, but we don't know how many numbers this actually represents. So we couldn't find the mean, but we could definitely figure out the median because it's marked on our box and whisker plot.
Yeah.
All right, what about this one? Here we have number 4 is a dot plot. So this dot plot is skewed. Would you say it's skewed right or skewed left?
Skewed right.
To the right. Yep. So since it is skewed, would I want to use the mean or the median to describe the center of the data?
Median?
Right. So this is, so anyway, even though there's not a outlier, there's not an outlier, right? Because there's 3 9s. So I wouldn't consider a 9 an outlier because there's 3 of them, but it does represent skewed data. So I would use the median, okay? So if your graph's skewed or if there definitely is an outlier, you want to use the median instead of the mean. What about number 5? How would you describe the shape of this data?
Symmetric?
Symmetric. So
The
what I
metric with a peak at 3.
perfect. That's a perfect answer. Symmetric with a peak at 3. I like it. So if I wanted to talk about the middle of this data, would I use the mean or the median?
The mean.
The mean, right? And obviously the median is going to be the same number, probably. It is. It's going to be the same number as the mean this time. But since it's so symmetric, absolutely, we would use the mean. All right, so I'm going to be quiet for a minute, and I want all of you to do number 6. I didn't tell you to grab paper, but do you have something to write on? So number 6, I want all of you to find out these 3 things: the mean, the median, and the absolute deviation, please. All right, did you guys find the mean?
Yeah.
What is the
Yep.
mean?
6.
6, right.
6.
So when we added up all these numbers over here, we got 48. And since there are 8 of them, our answer is 6. What about the median?
6.
6.
6.
6, right, because there's 4 lower and 4 upper numbers. So the median is 6. And then how do we find the mean absolute deviation?
you would subtract the mean from your numbers, and then you would add up all the numbers below and divide by the number by 8, because there's 8 numbers.
Yes. So do you guys agree 6 is 0 away, 3 is 3 away, 9 is, uh-oh, that's not right. 3 away. 5 is 1 away, 2, 0, and 8. Do y'all agree with me?
Yep.
Okay, so if we add these numbers, I get 6, 7, 8, 9, 10, 11, 12. So if I divide 12 by 8, what is the mean absolute deviation?
1.5.
1.5.
1.5. So someone give me a great sentence telling me what the MAD tells us about our data. Come on, you can do it. So, who can tell me? Come on. What does the MAD tell us?
Average value.
Well, close.
Away from the mean.
Yes, y'all put it together. Riley and Ava put it together. They said it's how far each data is.
We're now doing a lockdown drill. This is only a drill.
That's good. I don't want to lock down because someone's in the building. So basically the mean absolute deviation tells us how far each data item is on average from the mean, right? That's what it means. How far each data item is on average from the mean. Very good. All right, moving on. Everybody good?
Yeah.
Okay. So number 7, a class has a total of 32 students. According to this box, at least how many students made a score of 29 or higher? Ooh, that's a good question. All right, so 29 or higher would represent this part, right? From
Yeah.
here to here?
Yep.
That's
All right, and what percent of my data is that?
25.
25%.
Okay, I just gave you a big hint of figuring out the answer.
It's 8.
It is 8. Who said that?
Oh, Noah S.
Noah S. Awesome. So basically, if 25% of our people scored a 29 or higher, isn't 25% of 32 8?
Oh, yeah.
Y'all understand?
Yeah.
Awesome. That's a good question, right? Made you think.
Yeah.
Good. All right. So obviously number 8 answers my question I couldn't remember earlier about the interquartile range. Yep. So you guys already know this. So the interquartile range, what 2 numbers am I subtracting?
Q1 and the Q2.
Which are what?
20 and 29.
Yep. Well, I think it's 21, isn't it? So my interquartile range is 8, 29 minus 21. And then I already answered this earlier, didn't I? What does the interquartile range represent? Who remembers?
The range between
What percent of my data?
50%.
50.
The range
middle,
between
right?
50% of the data in the middle.
Exactly. It's the range of the middle 50% of my data. That's right. And then number 8, I think we already talked about that also. What information could we not find from a box plot?
The mean.
We could not find the mean. You are correct. Oh, that's it, you guys. So that's not too bad, right?
Yep.
Well, let me stop recording. How do I do that? How do I stop recording? Stop recording.